Hey everyone, welcome to the YouTube channel of DCC NIT-A. Myself Mayur, a second year CSC undergrad at NIT-A. Today I'm going to discuss the problem anti-lead cell guessing that came in Codeforces Global Round 17. The question says that we are playing a game on an n cross m grid in which the computer has selected some cell xy of the grid and we have to determine which one. That is, we have to find the hidden cell. For this, we will choose some k and some k cells and give them to the computer in the form of coordinates like x1, y, like that. In response, the computer will provide us k numbers, which are b1, b2 up to bk, where bi is the Manhattan distance from xi, yi to the hidden cell xy. That is like we'll choose some cell and give it to the computer, and the computer will provide us the Manhattan distance between our given cell and the hidden cell. So after receiving these distances, we have to determine the hidden cell. Now the main question is what is the smallest k for which it is possible to always guess the hidden cell correctly, no matter what cell the computer chooses. So like we'll be given the grid, and after that we have to ask the Manhattan distance from for some cells, and after that we have to guess like which is the hidden cell. And so in what is the minimum number of questions or queries that we have to ask for which it is always possible to guess the hidden cell. As a reminder, the Manhattan distance between two cells are a1 minus a2, the modulus of a1 minus a2 plus the modulus of b1 minus b2. So now let's take a look at the input. The input starts with t, that is the number of test cases, and then n and m, that is the number of rows and the number of columns. The values can lie in between 1 and 10 to the power 9. Now, note here that one of the most important thing in a question is the constant. You should always look at the constants carefully because they help us to identify some edge cases many a times. So we'll just see here like what can be the edge cases. Let's take a look at the smallest value. When both n and m is equal to 1. So when both are 1, so what should be the value of k? Now how to think? Like here see that if there is only one cell, so we can directly say that this will be the hidden cell, of course, since there are no other cells present. Do we have to even ask any question? No, right? As we can directly say that this is the hidden cell. So the value of k should be 0 in this case, as we did not need to ask any question. So the first case is when n is equal to 1 and m is equal to 1. Our the value of k is 0, right? This is our first case. And for larger values, like when we have got a bigger cell, like it can be have up to 10 to the power 9 as well as 10 to the power 9, 10 to the power 9 columns, 10 to the power 9 rows. So we'll see like how to figure out that. Now, before going to the bigger ones, let's take a look at the examples again. Here the examples like the first one is it has 2 rows and 3 columns. So the output is 2, and here it is explained here. You can see here how it is done. Basically, it's not of much importance because it doesn't give us much hint. We'll take a look at the second example here. It has 3 rows and 1 columns. So this is the diagram. So here, like how many questions are required, or like how many cells will you choose to find the hidden cell? So what should the first cell that you will choose? You have two options here, right? Let's say the first one is either you can choose this one. You can ask the Manhattan distance of the hidden cell and this cell, as well as you can ask from these ones, like these boundary ones. You have two options. Either you'll choose the middle one or you'll choose the edge ones. Now, let's take a look at both the cases. If you choose the middle one, now in that case, if you receive the value as 0, that is the Manhattan distance as 0, so you can directly say that this is the hidden cell, right? This is the hidden cell since the distance is 0. But in case you receive the value as 1, if you receive the value as 1, then the hidden cell can be this because this lies at distance of 1 as well as this. So, like, there are two possibilities again. You can't guaranteedly say which is the one, which is the hidden cell. So, you need to ask one more question. But rather, if we did it in another way, sorry, uh, if we did it in some another way where I took one of the boundary cells first. So, if I take this one as first, and now if I receive the output as 0, that is the response as 0, so I can say that this is the hidden cell. If I receive the output as 1, that is the response is 1. So this will be the hidden cell. And if I receive the response as 2, this will be the hidden cell, right? So in one question only, I can directly say which is the hidden cell. So this is a better one. Similarly, let's take a look at this one where the number of rows is 1 and the number of columns is 4. For this, I will do the same. Like initially, if I choose any one from the middle and I receive the value of, I receive the responses one, so it can be this one also as well as this one also. So like this doesn't help us. We need to ask more questions. So rather, what I'll do, I'll select one from the end, and now if I receive the values as zero, then this will be the hidden cell. If I receive the value as one, this will be the hidden cell. If I receive the value as two, this will be the hidden cell, and if I receive the value as three, this will be the hidden cell. So in one step only, I can guess which is the hidden cell. So from this, we derive our case 2. Case 2 is n equal to 1 or m equal to 1, right? It will have either one row or one column. In that case, k will be 1. This is the OR operator, right? Please note down, this is the OR operator. So this will be the second case. Now let's take a look for the bigger ones, bigger cells. Let's say this is a grid where there are 5 rows and 6 columns. Now, similarly, if I go like if I choose something from the middle, if I choose something from here, and I receive the value of k as 2. So, what can the hidden cells? The hidden cells can be this one, as this is at a Manhattan distance of 2. This one, this, then these are also possible, right? So there are total eight possibilities of hidden cells. Now we need to ask more questions in this case because we can't guaranteedly say which is a hidden one. So let's say if I take another cell now, if I take this cell and I still receive as 2, I still receive the value of k as 2. So not k, I still receive the response as 2. So again, there are two possibilities like this can be the hidden cell as well as this also can be the hidden cell, right? So there are two possibilities here. So still we could not find which is the hidden cell in two steps also. Like here you can see that this method is not optimized or like this method doesn't sound so good. We need to ask so many questions. Rather, what we'll do here, we'll go by the same intuition that we got from case 2. We'll go from one of the boundary cells. Let's say if I take one cell from the corner, let's say if I've taken this cell, this is the first cell that I put. Now, what are the various possible cells and what are the various possible distances here? If I receive the distance as 0, if I receive the response as 0, then I'm sure that this is the hidden cell, right? For 0, this is the hidden cell. Now, if I receive the distance as 1, the response is 1, then what are the possible values? This can be 1, this can be 1 for 1. Now, for 2, what are the possible cells? Like if I get the response as 2, then this can be one cell, this is also possible, this is also possible. For 3, what are the possible values? Then this is also possible, this is also possible, this is also, and this one also for 3. Similarly, for 4, what are the possible ones? This is possible, this is possible, and all these are possible, and so on. This is at the 4. So you can see that like we are getting some diagonal values. Like whatever be the values, we are getting them as in diagonals. So if I receive any value, let's say I have got 3 here. Now let's say I've got 3. So I can be sure that the hidden cells lie in between this one. The hidden cells will lie in between these diagonal cells only. No other cells can be hidden, right? Can be the hidden one. So for this, I will just focus on this one and we'll erase the rest. Okay. So now these are the 4 possibilities here. Now what I will do now for getting the actual hidden cell, I will do the same approach. That is, I will go by the same intuition. I will again go from one of the corner, one of the boundary. Let's say I have asked the distance from this position. Now from this position, if the distance comes as 0, if the distance comes as 0, then I am sure that this will be the one for 0, right? Now, if the distance comes as 2, if the distance comes as 2, then I'm sure that this will be the one, right? For 2, this will be the one. If the distance comes as, let's say, 4, then I'm sure that this will be the one. And if the distance comes as 6, I guess it will be 6. Yeah, it will be 6. So, the distance will be this one. So, you can see that all the values are unique. Like if you get 2, then you can directly say that this will be the hidden one. If you get 4, then you can directly say that this will be the hidden one. There are no two cells which are the same distance. So this is the basic logic. Like the case 3 will be from this, like case 3. For the remaining values of n and m, the answer will be 2. Because in 2 steps only, we can guess which is a hidden cell. Initially, we'll choose one corner. From that, based on the distance received, we can directly get one diagonal cell. That is a diagonal ones, which will have the hidden possibilities of hidden cell. And from the diagonal, we can take another cell from one of the boundary, and we will get the exact hidden cell in the next step. So that is the thing. And so here is a code. So I have taken t, that is the number of test cases, and then I have taken the input n and m. If both are 1, the answer is 0. That is here. If any of them is 1, then the answer will be 1. In other cases, it will be 2. So that is a simple explanation for this. I hope you understood that. In case you have any doubt, you can ask in the comment section. I'll try to resolve this as soon as possible. That's it for now. Thank you.